Absolutely, Ramon. Here's a set of 8 high-yield USMLE-style questions focused on the electron transport chain, ETC, and oxidative phosphorylation, including NADH versus FADH2, uncoupling, ATP yield, shuttles, and clinical relevance, e.g. aspirin toxicity. Each one uses your symbolic style, equals leads to decreases, equals increases, and I'll say the symbols out loud in the explanations. Question 1. NADH versus FADH2 entry points. Which of the following correctly identifies the entry points for electrons into the mitochondrial electron transport chain? A. NADH complex 2, FADH2, NADH complex 1, FADH2 complex 2. C. NADH complex 3H2, complex I. D. NADH ATP synthase, FADH2 complex 3. E. NADH cytochrome C. Correct answer B. NADH complex 1, FADH2 complex 2. Explanation: NADH donates electrons to complex I, while FADH2 donates to complex 2, which is at a lower energy level. This explains why NADH 2.5 ATP, while FADH2 1.5 ATP. Question 2. Final electron acceptor. Which of the following best describes the final electron acceptor in the electron transport chain? A. Carbon dioxide, B. Ubiquinone, C. NAD-MIND, D. Oxygen. E. Correct answer, oxygen. Explanation: SaSHA-O2 is the final electron acceptor in the ETC, leads to the formation of H2O. Accepting electrons allows proton pumping across the inner mitochondrial membrane, setting up the gradient for ATP synthesis. Question 3. ATP yield per electron carrier. How many ATP molecules are produced per NADH and FADH2 respectively via oxidative phosphorylation? A. 3 ATP per NADH, 2 ATP per FL. B. 2.5 ATP per NADH, 1.5 ATP per F5 ATP per FADP per NADH, 2.5 FADH2, D. 2 ATP per NAT per FADH, E. 2.5 ATP per. Correct answer B. 2.5 ATP per NADH, 1.5 ATP per FAD. Explanation: due to the energy level of entry into the ETC, NADH enters at complex more proton pumping, 2.5 FADH2 enters at complex 2, bypasses complex 1 less gradient, 1.5 ATP. Question 4. Shuttle system for cytosolic NADH. Which of the following shuttle systems allows cytosolic NADH to enter mitochondria and affects the total ATP yield per glucose? A. Cori cycle, B. Carnitine shuttle, C. Glucose-alanine cycle, D. Malate aspartate and glycerol 3-phosphate shuttles, E. Urea cycle. Correct answer D. Malate aspartate and glycerol 3-phosphate shuttles. Explanation: these shuttles transport electrons from cytosolic NADH into mitochondria. Malate aspartate, liver heart, leads to 32 ATP per glucose. Glycerol 3-phosphate muscle leads to 30 ATP per glucose. Question 5. Uncoupling of oxidative phosphorylation. Uncoupling proteins, like in brown adipose tissue, allow electron transport to continue but block ATP synthesis. What is the result? A. ATP production, heat. B. Electron transport. C. Proton gradient, ATP. ATP synthesis stops, but heat is produced. E. O2 consumption, heat. Correct answer D. ATP synthesis stops, but heat is produced. Explanation: uncoupling proteins. Permeability of inner mitochondrial membrane to H-bias. Proton gradient dissipates without making ATP. Electron transport continues, leads to heat production, especially in brown fat. Question 6. Effect of aspirin overdose. A patient with aspirin overdose develops hyperthermia. This is due to which of the following mechanisms? A. Inhibition of complex 4. B. Stimulation of ATP synthase. C. Uncoupling of oxidative phosphorylation. D. Inhibition of NADH dehydrogenase. E. Inhibition of cytochrome C oxidase. Correct answer C. Uncoupling of oxidative phosphorylation. Explanation: aspirin overdose leads to proton leak across inner mitochondrial membrane. Electron transport continues, but ATP synthesis. Energy lost as heat. Hyperthermia. Question 7. Anaerobic versus aerobic ATP yield. Which of the following best describes the ATP yield per glucose molecule under anaerobic versus aerobic conditions? A. Anaerobic 2 ATP, aerobic via malate aspartate 32 ATP. B. Anaerobic aerobic 26 ATP. C. Anaerobic 6 ATP, aerobic 30 ATP. D. Anaerobic 2 ATP, aerobic 18 ATP. E. Anaerobic 4 ATP. Correct answer A. Anaerobic 2 ATP, Aerobic via malate aspartate, 32 ATP. Explanation: anaerobic glycolysis yields only 2 net ATP glucose. Aerobic metabolism via malate aspartate shuttle leads to 32 ATP. Glycerol 3-phosphate shuttle leads to 30 ATP. Question 8. Brown fat versus white fat. Compared to white adipose tissue, brown fat, A, has fewer mitochondria and stores more triglycerides. B, contains uncoupling point proteins that generate heat. C, is primarily located in adults. D, is less vascular and less metabolically active. E, inhibits electron transport to preserve energy. Correct answer B, contains uncoupling proteins that generate heat. Explanation: brown fat is rich in mitochondria and expresses uncoupling protein 1, UCP1, leads to heat production without ATP generation seen in newborns and hibernating animals. Want a flowchart of the